Yesterday we learned how to solve a systems of equations using our graph. That is called solving a systems of equations graphically. Today we are going to use algebra. So I'm going to show you the substitution method, which is one method that I can use to solve a system of equations using algebra, algebraically. Next week we're going to learn how to solve it using another method algebraically. The steps involved is you are going to make sure that in one of the equations I can either solve for one of the variables, either get x or y isolated and solve. You are then going to substitute that solution into my second equation, where then I can eliminate that variable, so I am just solving for one variable. I then can solve for that first variable, use my answer to then solve for the second variable, and check both answers. So these steps become very clear when I do a couple of examples. So let us start, this is the homework for tonight. Let us start with question number 1. I get y to equal 4x plus 3, and y is equal to 2x plus 11. And I could very easily put this into my calculator and solve it using the graphing calculator. However, my directions say to solve using the process of substitution. So I need to use an algebraic approach. If I know that y is equal to 4x plus 3 in my first equation, I can now substitute in that 4x plus 3 into any area in my second equation that I see that y. So the second equation is y is equal to 2x plus 11. If I know in the first equation that y is really equal to 4x plus 3, where I see y in that second equation, I can substitute in the 4x plus 3, since y is equal to 4x plus 3. Now I have one variable. I am able then to isolate my variable and solve for x. And when I solve for x in this equation here, I am going to get x to equal 4. What I am now allowed to do is go back to that first equation. Y is equal to 4x plus 3. Let us substitute in 4 for x. And I could now solve for y. And I am going to get y to equal 19. Remember, when I go to solve this graphically, I'm going to get an ordered pair. So my ordered pair goes in the form of x comma y. So my ordered pair for this equation, systems of equations, would be 4 comma 19. But we're not done. We have to do a check. So let us check with that last equation that I have not worked with. And let's make sure 4 comma 19 is going to work. So 19 equals 2 times 4 plus 11. 19 equals 8 plus 11. And sure enough, 19 is equal to 19. So my answer is my ordered pair 4 comma 19. Okay, let us try number 2 now, again, using substitution. Here I tell you that y is equal to 2x plus 1. I already have a variable isolated. So what I am allowed to do in that second equation is every time I see a y, I can substitute in 2x plus 1. So I have x plus 2x plus 1 equals 7. Again, I eliminated a variable. I can now solve for x, combine my like terms, isolate my variable, and I get x to equal 2. Once I find what x is equal to, I can use that first equation, 2x plus 1, substitute in 2 for x, and solve for y. And I get y to equal 5. My point of intersection is in the form of x comma y, so my ordered pair would be 2 comma 5. Again, I would have to do a check. So I'm going to check with that second equation, and 2 plus 5, does that give me 7? And yes, it does check out. And that is how I solve systems of equations using what I call the substitution method.